Now I'm going to explain to you the physics background of projectiles while throwing a discus. Before we begin, we need to know what sine and cosine are. So, the vertical axis will equal y, and y is equal to sine theta, while the horizontal axis equals x, and x is equal to cosine theta. Now, remembering that x equals cosine theta and y equals sine theta, now I'll explain to you sine and cosine in parametric equations. Remember, when we have a triangle, there's always a hypotenuse. And for projectiles, this hypotenuse will always equal 1. And x will be the horizontal axis, and y will equal the vertical axis. This symbol here represents this angle, and it is called theta, a Greek symbol. Why use sine and cosine? Well, I'll tell you. Because sine theta equals opposite over hypotenuse. So if you're throwing the discus, opposite of the throw will be the vertical axis, and then here's the hypotenuse. So when you throw, the opposite will be across from you over hypotenuse. Then for cosine theta, it equals adjacent over hypotenuse, which is the horizontal axis. That is why cosine theta equals the horizontal. So when you throw a discus, the horizontal axis, A, will be over H, which is the hypotenuse. Now this is where we tie in cosine and sine with the vectors of a projectile. So when you throw a discus, there will be the vertical axis will equal Vy, and the horizontal axis will equal Vx. Now remember when I told you that theta equals the sum of the horizontal and vertical components. This stands true. Each line is exactly 10 units apart. And this yellow line equals V, which is also 10 lines. So, hence, the terminology is true. Vx plus Vy is equal to theta. Now, this is where it gets interesting. There are two parametric equations utilizing sine and cosine. First, we take cosine theta, and we set that equal to Vx over V. So Vx over V. Then, our final equation will equal Vx equal to V cosine theta. The same thing goes for sine. Sine theta will equal Vy over V. And then we get Vy equal to V sine theta. Here I made a sketch of a projectile in motion. So when a person throws a discus, starting about here, the projectile will begin looking like this. Then, once it reaches the max height, it stays at the same level, and then while it goes down, because of gravity, the axes flip, and then it ends just like this. Now I'm going to zoom in so you guys can take a look on your own as to what the projectile will look like in physics terminology.